This video provides a brief overview of smart modeling, how to create a single SketchUp model that can be used for both design and analysis purposes in Sefaira. Note that this approach really only works if you're able to organize a model from scratch. For tips on how to analyze existing complex models, we have other videos on the topic. The goal of a smart model is to build the model so that you're always able to isolate only the elements that are needed for analysis. And that means essentially the thermal envelope of the building, the boundary between inside and out, the floor plates, and any exterior shading elements that you want to analyze. Let's look at this model in section. What we want to be able to do conceptually is draw a continuous line around this building in section that represents the thermal envelope. That is the line that you will tag as walls, roofs, or glazing for Sefaira. I have a color-coded version of this section where I've drawn that thermal envelope boundary in red. Anything inside that boundary is either going to be a floor plate, an internal element like an internal wall or glazing, or possibly ignored. And anything outside that boundary is going to be either a shading element, like this small overhang here, or ignored. The two biggest hurdles to analyzing complex models generally are, one, the number of planes in the model. This bogs down the entity tagging process and the analysis engine itself to the point that it may not even work. And number two, the ability to clearly isolate that thermal envelope that we talked about. Often the models are not built so that that is easy to isolate. The smart modeling approach addresses both of these. So let's dive in on how to do it. First of all, I like to separate the building from the site. This makes it easier to work with, and oftentimes the site contains a lot of planes that are not necessary for analysis, particularly when you start getting into topography or landscape elements. Those often contain large numbers of planes. So what I've done in this model is I've essentially inserted the building model, which is in a separate file, similar to an XREF in AutoCAD, and you can always reload or update that model as you make changes. So let's go to that building model now. Here's the building model in a separate file. One of the first things I do when I'm creating a smart model is I set up a Sefaira scene. And this scene hides all the elements except for those that are needed for analysis purposes. You'll notice that I have used layers to organize my model. And there are a number of layers that are detail layers, such as structure, mullions of windows, parapets, that sort of detail you can put on independent layers so that you can turn them off. Now, I want to give credit to where credit is due. My model organization and layer structure builds on the system that was developed by Nick Sonder and Matt Donnelly, who developed this system in order to create documentation drawings using SketchUp and Layout. Now let's dive into some specifics as to how this model is organized. We'll start with two things that are typically the biggest hurdles: thick walls, or thick geometry in general, and complex windows. I'm going to go ahead and open the SketchUp Sefaira plugin, and I'm going to show the entities in this model. Now I've already done entity tagging, but what we're going to do is dive in and look closely at how I've gone about tagging the entities in this model. So let's start by looking at thick walls. I'll go into the top floor here. And what I've done is I've tagged essentially only the exterior side of this wall element as an external wall. The other side is tagged as an internal wall element. The easiest thing to do is oftentimes to tag all of the wall geometry as interior, and then go around the building and simply tag the planes that should be exterior. And this is because there often ends up being more geometry that's interior than exterior, and that way you end up making fewer errors and not accidentally having exterior walls on the inside. One other thing to watch out for is to avoid splitting planes in SketchUp unnecessarily. Every split that you make to a plane will increase the analysis time and increase the amount of time it takes you to tag that geometry. So you can see I've drawn a line here, I've split this wall into two planes. There's no reason for that. I can simplify everything by removing that and just having a single plane there. Now let's double check that the entity tagging is still correct. Yes, it is. Now if you do want to add detailed line work, I recommend doing that on a separate layer so that that layer can be turned off and you end up in your analysis version of the model with a clean single wall plane. Now you'll notice that I've organized this model into floors. So I do have, a exterior wall planes on each floor. I find that just makes it easier to navigate the model. You do end up with a few more planes, but I find that that is a trade-off worth making. Next, let's take a look at windows. I'm going to hide the entities for a moment and come over here and turn back on my window mullions. Now let's zoom into a particular window here. As you can see, I have modeled my windows as components. And within these components, I've modeled the glass separately from the mullions. That is, they're on separate layers. So I can turn off separately the glazing and the window mullions. What you'll notice is that the glazing is the full extent of the window. It goes all the way edge to edge. If I unhide the rest of the model, you can see it fully fills in that rough opening of the window. And that allows me to have a full envelope and not to have extra penetrations for things like daylight analysis. And then the mullion just sits directly on top of that glass. I can do that because the properties of the window, like the U factor, already take into account the window frames and the window mullions, because what we're looking for in that input is an overall assembly U value for the window. I use a similar strategy for curtain walls. You'll notice that these curtain walls are just large expanses of glass, single sheet, and I have overlaid the mullions on top of that in a separate layer. One other thing that you may notice here, if I show the entities, I've tagged the spandrel glass in these window elements as wall and the rest of the glazing unit as glass. So even though they're both reading from a design standpoint as part of the curtain wall, I've differentiated between the portion that has some insulating value in it and doesn't let light through, and the portion that is truly glass. Okay, now let's take a look at floors. Move this back over here. Now floors, you have to be careful in the same way that you have to be careful with thick walls. If you're modeling with thick geometry, you have to make sure that only the top surface of that floor plate is actually a floor. Now if you look at what I've done here, I actually have modeled my floors such that it's just a thin plane, and then there's a ceiling plane on the next floor below, and this ceiling plane is tagged as an internal surface. I could also tag it as a shading element. Essentially both of those types of elements are adiabatic. They have no thermal transfer between interior and exterior, but they are used to block light, both for shading purposes and for the purposes of daylight analysis. Let's look at a couple other special conditions here. You'll notice that I've tagged the underside of my cantilevers as a roof surface. You could also tag it as a wall. It depends to some extent on how you have detailed it and what level of insulation and construction type is most appropriate. So if it's more similar to your wall surface, tag it as a wall. If it's more similar to your roof construction, tag it as a roof. Let's go back to floors for just a moment here. There's one other thing that I want to mention with floor surfaces, and that's that a lot of horizontal geometry may be automatically tagged as a floor. So for instance, these little pieces of window header that you see here, or some of these horizontal wall bits, by default that's likely going to be tagged as a floor surface. And it can be easy to miss those small pieces of geometry. But you want to make sure that those are tagged as something else, not as a floor, for a couple reasons. One is the floor area is used to calculate internal loads like occupancy, lighting, and appliances. And so if you get the floor area wrong, it can have a cascading impact on all of those other inputs. Second of all, Sefaira may try to create zones out of each piece of floor. And it may fail to create a zone from something that's actually a windowsill, because obviously it's not bounded on all four sides and it's very small. And that could potentially cause the analysis to fail. So an easy way to check for that is to go to the entity palette and to isolate the floor type. The entity palette will also tell you how many floor elements are found in the model. In this case, it seems to have found 751. That seems like an awful lot to me. So chances are there is something amiss here. I don't think I have 751 floors. So that's a good indicator that I need to start looking, and perhaps the bottom of some windowsills and my window components may be mistagged as a floor. That would be a good explanation for that. One way to begin to check this, because even when you isolate floors, it can be difficult to see the geometry when you have a complex model. And this is where going on a kind of room by room basis and a floor by floor basis can be very helpful. So if I wanted to check some of those windowsills, for instance, I could click into that's my interior wall. I could click into my exterior wall element, if I can here. There we go. And we can quickly begin to check for any yellow surfaces that we see here. You can also, when you're in this, you can select all the geometry. And this plugin will tell you how many of the floor surfaces you have selected at once. So I have 0 floors selected as part of this wall element. That tells me that I don't have any stray floors in that bit of geometry. If instead I did the same thing for my actual floor plate, you can see that it has 1 floor identified. Okay, so let's talk about overhangs and parapets and geometry that seems to penetrate that thermal envelope of the building. We have a couple examples here. So I have one large overhang here at the ground floor. So how do you go about modeling that? Well, it depends to some extent, again, on how it's constructed. Is this overhang thermally isolated from the rest of the structure, or are you designing this more or less as part of the roof structure? What I've assumed here is that this is more or less all part of the same structure. So I've tagged the top all as roof. That means the entire surface has heat transfer through it. If I felt like the overhang was in fact very thermally separated and shouldn't be counting against me from an energy standpoint, what I could do is I could actually score this roof. Let me go ahead and do it here. I could come into this roof element, and I would have to figure out exactly where the overhang extends to, but I could essentially mark out that surface and tag the overhang portion of it purely as a shading element. So this would be a case where I've done a lot of good work on my detailing and I don't want to count that shading against me in terms of having thermal transfer between inside and out. So both surfaces, all surfaces of this shading element would be tagged as shading. You'll see I've also done a similar thing here where this curtain wall kind of appears to extend out beyond the, extends down below the where the actual thermal envelope of the building stops, kind of for an aesthetic effect. So that portion that's beyond is not actually part of the envelope. I've tagged simply as a shading element. Okay, let's talk for just a minute about structural elements. One of the things I modeled in this building that are currently off are structural elements. I can go ahead and turn them on again. So you'll see there are columns and beams in this building, and these really are not part of the thermal envelope. I don't really need to include them for interior partitions because they're not blocking a whole lot of light in terms of daylighting analysis. So I model them on a separate layer that can be turned off easily. Similar logic works for most interior elements. Things, especially complex elements like railings, which can have a lot of parts, staircases, interior millwork, all of that stuff can add a ton of geometry to your model and doesn't really affect performance either from an energy or a daylighting standpoint. Even if you're doing daylight analysis and you want to understand the impact of interior partitions, what I would do is model those partitions as simply as possible and have that simple version on its own layer, and then add the detail to that on different layers that can be turned off. So let's take a quick look at how I've done the interior partitions here. I'll turn the structure back off. Let's show our entities again. Good, and let's dive into one of these floors here. Let's take a look. So I have modeled all of my interior partitions, the kind of simple version of it without trim or doors or millwork or anything, as their own element in their own group. Now, I've grouped it together. That makes it very easy to make sure that all of this geometry stays tagged as interior, an internal wall. Because what you can do is when it's a group, you can right-click and tag the entire group at once. And that's one way to very quickly be able to keep your model up to date if you group things that are going to be tagged as similar elements. All right, let me mention one thing about materiality in the model. One of the things that I've done here is in my smart models, I try to use generous use of the SketchUp materials. So rather than drawing every brick or every wood slat, if you have a slatted screen, I just use the materials and apply them to a simple surface for that. If you do have something where you want to model in that amount of detail, like let's say a slatted screen where you really want to draw each slat, I'd recommend doing that as on a separate layer that you can turn off. And if you want to include the kind of shading impacts of that, create a simple version on another layer that you can turn on instead. All right, so let's go ahead and give this model a run through the analysis engine. Now, before I do that, you should always make sure to check the entities. And what I recommend is going through and isolating each entity type individually, going through and isolating roof, floor, wall, shading, etc., and making sure that only the elements that you want to be tagged as that are tagged as such. Again, it can help to go floor by floor if you've organized your model that way, just so you can easily see where those elements are. And again, what we've tried to do here is tag the exterior thermal envelope of the building. Anything inside that is interior geometry. Anything outside that envelope is shading. So this looks good to me. Let's go ahead and set up our analysis and run it. And here is the analysis. Now I fast forwarded through some of that analysis time, but it only took a couple minutes, which is not bad for a model of this size. One thing I'd like to mention is that with complex models like these, You should also check the results, as the results can sometimes be an indicator if some of the modeling is incorrect. So if the results are very unexpected, or if they're wildly different from a previous version of the same building, that's an indicator that something may be wrong with the geometry, especially things like floor area or glazing facing the wrong direction. Those things can very quickly throw off analysis results. So let's also take a look at the daylight visualization. Let's open this up and do an annual simulation. So there you have it. That is how we do energy and daylight analysis using a complex smart model. And this is a great way to make sure that you can always analyze your building at any point, even as the design progresses and gets more detailed.